Being born out of our pipeline project with Taylor, we created a Turing-complete language that can be interpreted by the EVM, with operations that can run both on the stack or on memory frames. This allows Taylor to do recursive operations that are not possible now with Solidity or Yule. While building the Taylor interpreter and other EVM interpreters, neither Solidity nor Yule was flexible enough to build them efficiently. So we created a macro language exactly for this purpose, MASM, Macro Assembly. And today we are announcing the next step for Taylor, a compiled language. Taylor EVM is an intermediate language that gives developers access to all EVM instructions and to several out-of-the-box compositions. It supersedes MASM, and its canonical form has Lisp-like parentheses. We are in the Cometh debugger. Taylor EVM compiles to EVM assembly and bytecode. We have defined a smart contract that implements the Fibonacci function. The function named fib is called here with the call data from the transaction. And then the result is stored in memory and then returned. The function definition is here, and it is defined in a recursive way. The fib function calls itself 2 times and then adds the result. So now we can deploy this bytecode on an Ethereum network. And let's see the internals of executing Fibonacci of 16. We get the result here, and now the execution steps. There are 85,745 execution steps, with 318,044 execution gas cost. And now we can find the place in the code where the Fibonacci function begins. It is here at PC18. And you can see it takes the value 16 from the stack. So we are now at execution step 6, PC18. Just by changing the iteration number, we can see every time the execution calls the fib function and with what arguments. Iteration 1, fib of 14. Iteration 2, fib of 12. Iteration 3, fib of 10. Iteration 4, fib of 8, and so on. Or we can go at the point in code where we add these 2 intermediary results. Which is here at PC55. Let's go at iteration step 1590. And this is one of the intermediary results of the recursive Fibonacci calls. Taylor is presently used as a language interpreted by the EVM, compiled by the EVM, and interpreted by JavaScript. Therefore, a developer could use the same language to develop Web3 dApps. This technology was created by and for volunteers at the Laurel project. You may join this tech effort. Link in the description.